The mirror that makes time go backward was locked away for years because it can rewind reality itself. Hidden in that lab, away from curious eyes, sits an object unlike any ordinary mirror. Most mirrors show your reflection. This one, it makes time itself run backward. No magic spells, no CGI, just cold, bizarre physics. And once you see how it works, you'll never trust your own reflection the same way again. In 2018, researchers at the University of Queensland made headlines. They built a time-reversing mirror, not one that literally turns back time for humans, but for light. When a pulse of light hit it, the wave's properties rewound as if played in reverse. Imagine shouting at a wall and hearing your words unspeak themselves. This experiment wasn't a parlor trick. It was precise control over how waves behave, using metamaterials engineered substances that can twist reality's rules. This wasn't just a cool stunt. It hinted at new ways to undo physical processes in real time. The key is metamaterials structures smaller than the wavelength of light. By designing these in precise patterns, scientists can control how waves move, bend, or even reverse. In the time mirror, the metamaterial reflected light in a way that its wavefront flipped. That's like watching ripples on a pond flow back toward the pebble. The setup involved lasers, ultra-fast sensors, and software capable of measuring light changes in trillionths of a second. It's extreme engineering meets experimental physics, a level of precision where even a vibration from a passing truck could ruin everything. When you look in an ordinary mirror, you see light bouncing back instantly. But a time mirror changes the phase of that light, effectively rewriting its journey. Imagine you spill milk on the floor and, instead of mopping, the droplets leap back into the cup. The actual mirror is not shiny like glass. It looks more like a piece of advanced circuit board fused with optics. In the lab, it's surrounded by wires, lasers, and sensitive detectors. It's not meant for makeup touch-ups, but for bending reality's playback button. This trick isn't just for light. In 2014, scientists demonstrated a time reversal mirror for sound waves. They recorded an acoustic wave, processed it, then re-emitted it so it traveled exactly backward through the same medium. The sound retraced its path perfectly, like a laser pointer in audio form. Combine this with the light experiment, and you start to see a strange possibility. If you can reverse waves, maybe you can reverse the effects of certain events. Not people aging backward, but undoing damage in communication systems or even medical imaging errors. The time mirror could someday act like a universal undo button for wave-based technologies. In telecommunications, reversing a signal could clean up distortion. In medicine, ultrasound waves could be sent into the body and then recalled to remove noise from scans. The ability to run a wave backward is like rewinding a video to fix a frame, except the video is reality itself. This isn't fantasy, it's just exploiting the rules of wave physics. But making it practical will require hardware that's faster, smaller, and able to handle real-world messiness outside a quiet, vibration-proof lab. In physics terms, the time mirror works by changing the medium so abruptly that it flips the wave's time direction. It's like suddenly flipping a playing card. One instant it's face up, the next it's reversed. This demands ultra-fast control, often at the femtosecond level, 1/quadrillionth of a second. By tuning the properties of the metamaterial, scientists can trick the wave into thinking it's moving backward. It's a dance between speed, precision, and material design, and even the smallest delay can ruin the effect entirely. Here's the spoiler. The time mirror doesn't actually reverse time. It reverses the direction of a wave's information. You can't step through it and visit the dinosaurs. But, in its own way, it is time travel for the signal. A light pulse hitting the mirror behaves as though it came from the future toward the past. It's a subtle, strange effect that bends our language as much as it bends the laws of nature. For now, it's strictly a physics lab marvel, but its implications could sneak into everyday tech sooner than you'd expect. The time reversal concept wasn't born yesterday. In the 1960s, Soviet physicists theorized ways to manipulate wave direction using sudden changes in media. Those early ideas stayed mostly on paper until computing and material science caught up. Today's time mirrors are their dream realized. Back then, they imagined possible applications in sonar to find objects underwater by reversing echoes. The ocean is actually where time reversal found its first real-world success, decades before lightwave versions. It's a reminder that some futuristic breakthroughs have very old roots. Unsurprisingly, defense agencies took note. A time-reversing system could help in underwater detection, radio communications, and even jamming enemy signals. If you can reverse a signal perfectly, you can pinpoint its source or make it vanish entirely. While the Queensland experiment was civilian science, the underlying tech attracts classified attention. It's another case of cutting-edge physics, straddling the line between beneficial innovation and, well, something that could get locked away in a secure facility for decades. Imagine sending ultrasound waves into the body, then reversing them so they refocus exactly on their starting point. This could target tumors with extreme precision or undo distortions in imaging. Medical researchers already use partial time reversal in experimental cancer treatments, concentrating heat or sound waves right where they're needed without damaging nearby tissue. A perfected time mirror for sound could make such techniques far more accurate. Suddenly, what started as a physics curiosity starts looking like a life-saving medical tool. Interestingly, nature has its own form of time reversal effects. In certain crystals, waves can scatter in ways that mimic reversal. Even in chaotic systems like the ocean or the atmosphere, echoes can retrace their paths under the right conditions. But humans can now do it on demand, in controlled environments, and with different types of waves. That's the real leap forward, turning a rare natural quirk into a reliable switch we can flick whenever we want. Think of time mirrors like this. You spill coffee. Normally, the liquid spreads out randomly. But in a perfect time reversal, every droplet would trace its path back, reforming in your cup. That's impossible for coffee molecules. But for waves, it's achievable. In the lab, scientists use this analogy to help students visualize what's happening. The real challenge is that any interference, dust, air turbulence, tiny imperfections, throws the rewind off track. That's why these experiments happen in super stable, meticulously calibrated environments. Some physicists are curious. Could time reversal mirrors work on quantum waves? In theory, manipulating a particle's wave function backward in time would allow unheard of control over quantum systems. In practice, quantum states are incredibly fragile, and measuring them usually destroys the information. Still, research in quantum optics is inching toward these experiments. If successful, it could mean undoing quantum errors, something that would supercharge quantum computers and communication systems. To some, reversing waves sounds like breaking physics, but it's not. The laws of physics are time-symmetric for most interactions, meaning they work the same forward and backward. We just rarely see backward motion Because reality is messy. Entropy pushes everything toward disorder. The time mirror sidesteps entropy locally for a very short moment. It doesn't violate the rules. It just plays them in reverse. It's like watching a chess game backward. You can retrace the moves, but you can't change the fact the game already happened. One day, time mirrors could be hidden in the gadgets we take for granted. Your phone could use wave reversal to boost signal clarity. Hospitals might have imaging devices that instantly clean scans. Even concert halls could employ acoustic time mirrors to make sound perfect for every seat. The tech could vanish into the background, just another invisible layer of engineering making life smoother. Most people might never even know they're using it. Here's where it gets unsettling. A time-reversing system for radio or audio could be used to reconstruct conversations from stray signals. In theory, with enough data, you could rewind a communication and recover what was said, even if you weren't listening at the time. Privacy advocates warn that as time mirror tech gets better, so will eavesdropping tools. It's the same with all new tech. It's a double-edged sword. Pop culture has toyed with time reversal for decades. Think Benjamin Button or movie fight scenes played backward. But here, it's no longer fiction. A lab full of quiet, humming machines can actually reverse a tiny slice of reality. It's not as flashy as Hollywood. No glowing portals or shimmering air. But it's arguably stranger, because it's real. When scientists publish their papers, they're not writing scripts. They're writing history. Researchers are working on making time mirrors portable and less finicky. Right now, they're trapped in bulky lab rigs. But imagine a shoebox-sized device that can reverse any wave it captures. It could revolutionize communications, medicine, and security overnight. Of course, like all powerful tools, who controls it will matter just as much as the tech itself. The race to miniaturize might decide whether time reversal is a common household tool or a closely guarded military secret. We can't step through a time mirror to fix our mistakes, but for light, sound, and maybe even quantum waves, reversal is already here. What started as a strange physics experiment could soon reshape medicine, communication, and privacy. The past isn't coming back for us, but for some parts of reality, it just might. And when that happens, will we be ready to hit rewind?